Hello everyone, welcome to my Capstone project presentation. My name is Vamsi Ramayanam. Today I'll be more than happy to walk you through the Capstone project, which is AI in diabetes prediction. As part of this, I have built an app called the Diabetes Prediction, which is designed to predict the risk of diabetes in individuals, and it helps healthcare providers to make more informed decisions. So diabetes is a growing global health concern, and early prediction is key to preventing complications. My app utilizes machine learning to assess individual risk factors and provide real-time data-driven insights into person's health. So the app serves two key audience: patients who input their health data to assess their risk, and healthcare providers who can monitor multiple patients and track their health over time. So without any further delay, let's dive more into the key features of the app. So So this app predicts the likelihood of diabetes using data like BMI, glucose, insulin, and few other key parameters that user will enter. And it also has a feature to upload retinal images to predict. It helps healthcare providers diagnose diabetes and retinopathy. So it predicts diabetes risk from user input and retinopathy severity using images that user will have option to upload. So I've used a random forest, XGBoost, and CNN models for the predictions. So the app uses Flask for the backend and HTML, CSS, JavaScript for the frontend, ensuring ease of use for patients and healthcare providers. User inputs healthcare data or uploads retinal images, which are processed by machine learning models to return predictions. Random forest, XGBoost are used for diabetes prediction, and CNN for retinopathy prediction, ensuring accuracy with both structured data and images. As part of the data processing, all the missing values are handled by replacing with the median values to ensure the quality of data. And it is trained on smart enhanced data. It balances the dataset using a smart generating synthetic data points for minority class and improving model performance. Random forest and XGBoost are used for diabetes prediction. And as I mentioned, random forest is for ensemble of decision trees, while XGBoost uses gradient boosting. Combining random forest and XGBoost in a voting classifier ensures accurate predictions by leveraging both models' strength. SENN is used for retinopathy image classification and effective for image-based task consisting of convolutional, max pooling, and dense layers. So the retinopathy model uses the data augmentation to expand the dataset and reduce overfitting. The CNN includes convolutional layers, max pooling, and the dropout to classify retinal images into severity classes. For diabetes, the voting classifier combines random forest and XGBoost to improve prediction accuracy. Both models are trained using smart resample data and train generator. After training, the models are saved using a joblib and TensorFlow Keras for deployment. The front end, as I mentioned, I've used HTML, CSS, and JavaScript, ensuring an intuitive interface for data entry and image uploads. Flask is used for routing, managing user inputs, and calling the models for predictions. Uh, SQLite stores uses data and prediction results integrated with the SQL Alchemy for easy data handling. Flask login manages users login, ensuring secure access for patients and healthcare providers. After data entry, the model's predictions are displayed in real time for diabetes and retinopathy. So the app has multiple routes. For example, the data input where the user had option to enter, and prediction route where the user can see the predicted data and has a dashboard. There are so many other routes. As we walk through that in the main presentation, we will explore more on this one. The prediction flow, data from the user is passed onto the relevant model, which processes it and returns a prediction. Both models are used. Both models are loaded using joblib and TensorFlow with predictions made via predict model. The Flask login manages user sessions, providing secure access to protected pages. Predictions are stored in SQLite, um, allowing users to view historical data and track health progresses. The Flask login handles user login, ensuring that only authorized users can access protected resources. And BaseCrypt is used to hash and securely stored passwords, protecting them even if the database is compromised. Sessions expire after 3 minutes of inactivity, preventing unauthorized access if a session is left idle. The RBAC ensures that healthcare providers can access all data while patients can only view their respective own data. Users can securely log out, terminating their sessions and ensuring no sensitive data is exposed. This SQLite stores users' data and predictions for easy retrieval. Users can view previous predictions on their dashboards, enabling them to track health progress. Uh, Visualizations charts are used for interactive visualizations like glucose levels, BMI, and risk levels, which can be tracked over time. And there are various graphs that are built to show the different visualizations for the users to give a better perspective of their results over time. The app is deployed on Azure Web Apps, providing scalability and global access. The diabetes and retinopathy models are hosted on Azure, allowing real-time predictions. As of now, the CI/CD pipeline is not implemented yet to deploy the latest changes, but the code is there in the GitHub. In future enhancements, we will also integrate different sources of data that can be used, that can pipelines can be built to automatically ingest the data and then have these predictions real time. Users worldwide can access the app, scaling it for a large user base. And the cloud deployment is secured using HTTP for secure data transmissions with authentication and session management for data access controls. Thank you. And before we go further, here's a glimpse of the app where user can log in with their respective credentials. Here, the user can select the role, either a patient or a healthcare provider, whatever the login, whatever is being registered initially. In the login, they see the dashboard with their historical information. These are the different tabs where user can key in their data and then click on the prediction, and as well as he can as well see the past historical data. And then he has an option to upload retinopathy image here and then click on for predictions. And the visualizations tab, we have a different visualizations where user can interact with this. And we have an option to leave a feedback and recommendations, and then they can as well leave a rating for this and click on submit for this. So we will explore more on this app in the final presentation. Thank you for watching.